Hi students, welcome to Future Dr. NEET Academy for the crash course in NEET Physics. Now the topic we are going to discuss is from chapter 13th one, Nuclei. Already we have finished previous 12 chapters in the previous sessions. Now 13th chapter, Nuclei. In nuclei, we want to learn some of the parameters, some of the terms, that is atomic number. What is atomic number? Atomic number is the number of protons in the nucleus is called the atomic number. That is, inside a nucleus, proton as well as neutrons are present, and electrons, where is the electron is situated? Electrons revolving around the nucleus. And here, number of protons inside the nucleus, only protons inside the nucleus only, atomic number. It is noted by a symbol Z. Already we may study that any element can be represented as X, Z, A. Is it so? X is the element, symbol of the element. Z is the atomic number and A mass number. These things only we are studying. Okay, so what is atomic number? It is noted by a symbol Z and it is the number of protons in the nucleus is called atomic number, and another one mass number. Mass number is noted by a symbol A and it is the total number of protons and neutrons. That is sum of the protons and neutrons inside a nucleus. That is called mass number. And number of protons, electrons, nucleons and neutrons, that and all. Number of protons in an atom, already we discussed, that is only atomic number Z. Number of electrons in an atom also Z only. This is equal, that is number of proton and number of neutron, number of proton and number of electron are equal only in one condition, that is when the atom is in stable state. Okay, when the atom is in stable state only, number of protons and number of electrons are equal. And number of nucleons. What is nucleons? Say, what is nucleons? Define nucleon. Nucleon is nothing but nuclear particle, that is proton plus neutron. Proton and neutrons together called as nucleon. Okay, protons and neutrons are together called as nucleons. And the number of nucleons in an atom is A. We said no, that is total number of protons and neutrons. Instead of that, one separate name is given, term is given, that is nuclear particle as nucleons. So number of nucleons is A. And number of neutrons in an atom, N equal to A minus Z. N equal to A minus Z. So from this we can find, here N is not there, so from this N equal to A minus Z, you are able to find the number of neutrons. Any doubt in this? No. Some more terms we want to study based on the same number of protons or same number of neutrons or same atomic number or same mass number, we will call different type of element, that is atoms of an element which have same atomic number but different mass number are called isotopes. What are isotopes? Atoms of the element having same atomic number but different mass number are called isotopes. That is atomic number same, mass number are different. We can keep as A1 and XZ, A2, different mass number. Can you say any example for this? Example for isotopes? Carbon. Come on, say the formula. Carbon means C6, 12, another one C6, 13, 14. They are all isotopes of carbon. Similarly, another example, hydrogen. Hydrogen H11, protium. H12, what is H12? Deuterium. H11, this is H11. H1 another one H12 and H13. These are example for isotopes. Same atomic number 111 but different mass number 123. Same way for carbon, same atomic number 66 but different mass number as 1214. Okay. And some more terms we want to learn, that is isotones. What are isotones? Isotones are the element whose nuclei have same number of neutrons. Same number of neutrons are called isotones. Example, that is sulfur S1636, chlorine Cl1737, sulfur S1636, chlorine Cl1737, argon Ar1838, argon Ar1838, K, what is K? Potassium, potassium K1939, calcium Ca2040. And here and all, how you will find the neutron number? Neutron number N equal to A minus Z. Then 36 minus 16 or 37 minus 17, 38 minus 18, 39 minus 19, 40 minus 20. For all, you will get N equal to 20. So number of neutrons is same. That is, what is a isotone? That is some element having, but different element, having different atomic number, different mass number, but same neutron number are called isotones. Okay. Isotones are the elements having different atomic number, different mass number, but same neutron number are called isotones. Next, isobars. Atoms of same mass number but different atomic number. Mass number is same but atomic number different. Example, argon, argon Ar1840, potassium K1940, calcium Ca2040. In all the place, A is same. A is same as A equal to 40. But Z value different as Z1 18, Z2 19, Z3 20, different atomic number. Okay, that is called isobars. What are isobar? Isobars are the elements whose mass number is same but different atomic number are called isobars. Apart from that, isomers is there. Atoms having same mass number, same atomic number but different radioactive properties. In chemistry also you studied isomer, that is different structural properties in chemistry. In our nuclear physics, different radioactive property are called isomers or nuclear isomers we can say. Atoms having same mass number, same atomic number but different radioactive properties are called isomers or nuclear isomers. Why is mentioned nuclear isomers means we should not confuse with the chemistry isomer. In chemistry isomer, that is atoms having same mass number, same atomic number but different structural property, different in structure. Ketone with alcohol, like that you may study. Okay, and how is the, what is the example means cobalt. Cobalt 58, cobalt 58M. Okay, 58 is one cobalt and cobalt 58M is, 58M is nothing but it is a metastable state. Metastable. That is only mentioned as 58M. And cobalt 58 has half-life 71 days. And cobalt 58M has half-life 9 hours. Okay. So that is half-life is one of the important radioactive property. Okay. So cobalt 58 has 71 days, cobalt 58M has different half-life. So this is the best example for isomer, nuclear isomer or radioactive isomers. Okay. Can we move to next? Nucleus of an atom. Rutherford discovered nucleus. First, Rutherford only discovered nucleus, and protons and neutrons are reside inside a nucleus. Before the discovery of nucleus is, that is atoms outside electron, inside proton, like that only they have assumed. And protons and neutrons are residing inside a nucleus. Protons denote charge on nucleus. Protons denote charge on nucleus. That only we mention as X, Z, A means this represents charge. And charge on the nucleus is Z into E. What is E? E is the magnitude of the charge. That is the charge of the electron means minus 1.6 into 10 power minus 19. 1 E, that is the magnitude of charge equal to 1.6 into 10 power minus 19 coulomb. And charge on nucleus is Z into E. For example, hydrogen atomic number 1. So 1 into E. Helium atomic number 2. So 2 into E, like that. Okay. And Z proton, where Z is the proton number lies in the nucleus. And mass of nucleus is due to protons and neutrons. That only we said protons plus neutrons. That only mass number. And electrons do not lie in the nucleus. Electrons are present outside the nucleus. Density of nucleus is 10 power 14 gram per centimeter cube. Density of nucleus is 10 power 14 gram per centimeter cube. And if we convert this gram per centimeter cube to SI unit, kilogram per meter cube, then gram to kilogram into 10 power minus 3, centimeter to meter 10 power minus 2, whole power 3. On simplifying into 10 power 3 we will get. So 10 power 14 into 10 power 3, 10 power 17. So density of nucleus is 10 power 17 kilogram per meter cube. Okay. And radius of the nucleus are equal to R naught into A power 1 by 3. Here R naught is the constant value, its value is equal to 1.2 into 10 power minus 15 meter, and 10 power minus 15 meter is having separate one term. What is the name of that? 10 power minus 15 meter is equal to 1 Fermi. Okay, it should be read as Fermi. 1 Fermi equal to 10 power minus 15 meter. Just like 1 angstrom, 10 power minus 10 meter. 1 nanometer, 10 power minus 9 meter. 1 micrometer, 10 power minus 6 meter. Like this, 1 Fermi is equal to 10 power minus 15 meter. There may be one question asked, what is the difference between, one student only asked this, what is the difference between Fermi and femto? Can you say what is the difference between Fermi and femto? Fermi means 10 power minus 15 meter. Femto means 10 power minus 15. That's all. It may be femtosecond, 10 power minus 15 second. Any unit. Femto means just 10 power minus 15. One multiples of 10, that is femto. Just like kilo. Kilo means how much? 10 power 3. Okay, 10 power 3 is kilo. 10 power 3 meter means kilometer. 10 power 3 gram equal to kilogram. 10 power 3 liter, kiloliter. Like that. Okay. Then, so radius of the nucleus is R equal to R naught into A power 1 by 3, and therefore radius of the nucleus is approximately 10 power minus 15 meter. Very smallest one. And nucleon equal to neutron plus proton. That is a nucleon is nothing but neutron and proton, or together called as nucleon. Nucleon means nuclear particle. That is only nucleon. Mass defect. Mass defect is the difference between the mass of the nucleon with the mass of the nucleus. Actually, neutron and proton combinedly formed nucleus. But mass of the nucleus is less than mass of the proton and the neutron. Then the difference in mass of the nucleus and constituent particle mass as neutron and proton, that is called as mass defect. That is equal to delta M. Okay, mass defect is delta M. Then delta M equal to N into Mn. N may be written as A minus Z. That only we mentioned already. Because in most of the nuclear element mentioned as X is at A only. So at that time we have to search where is N. That is N equal to A minus Z. Or delta M equal to N into Mn. What is Mn? Mn is the mass of the neutron. Plus ZMP. Z is the proton number into MP. MP is the mass of the proton minus M is at A. That is nothing but mass of the nucleus. That is Z A. Okay. That only mentioned here. And delta M is decrease in mass during the process of formation of nuclei. That change in mass only helps to build up the nucleus or formation of the nucleus or binding the energy. That only we are going to discuss as binding energy. Next topic. Mass defect into something will give binding energy. Okay. Noted, no? Previous. Noted? Electron volts. Some of the units we are going to discuss only for atomic physics and nuclear physics. That is electron volt and atomic mass unit. What is electron volt? Electron volt is the unit of energy in atomic scale or nuclear scale. That is only electron volt. We use many places in problems and all for conversion of EV to joules or joules to EV, like that we have discussed. And what is electron volt? It is the unit of energy in atomic scale or in nuclear scale. And it is defined as the energy acquired by an electron when it is accelerated through a potential difference of 1 volt and is denoted by EV. And is denoted by EV. And what is the relation between 1 EV and joules? 1 EV equal to 1.6 into 10 power minus 19 joules. This is the conversion of electron volt and joules. Just like suppose in problem formed in one particular problem, its length is given in centimeter. You want to convert into meter into 10 power minus 2. That is 100 centimeter equal to 1 meter based on that. Like that we have to learn or know the conversion between EV and joules. That is 1 EV equal to 1.6 into 10 power minus 19 joules. Okay. So EV is already, I said, it is a unit of energy in atomic scale. Like that, unit of mass in atomic scale is AMU. AMU, or it may be AMU or another unit just to U, 5U, 10U, like that. That U is nothing but same as atomic mass unit and it will be read as unified mass. Okay. U and AMU same. U equal to AMU same meaning. Okay. U is a unified mass, AMU is the atomic mass unit, that's all. Only name only different, but conversion, value, formula, everything same. Okay. Now, atomic mass unit is 1/12 of the actual mass of a carbon atom of isotope C612. It is denoted by AMU or just by U. Just now only I said U. So what is U? U is a unified mass. Okay. Here there is a one question. It is 1/12 of the actual mass of carbon atom. Why 1/12 of the carbon atom? Why not be some other element? Try to find a solution for this question. Okay. What is atomic mass unit? Here in definition, it is the 1/12th of the mass of the carbon atom. Why should be carbon? Why should not be nitrogen, hydrogen, carbon? Carbon is given, cobalt, nickel, potassium, calcium, lot of elements are there. Is it so? Periodic table, lot of elements are there. Why they mentioned carbon? 1/12th of the carbon.
Organic, sir.
Yes?
Study of carbon is organic.
Okay. Study about except carbon is inorganic. Why should not we use inorganic compound? You are coming somewhat nearer, but exact. I want exact answer. Okay, for example, nitrogen we are taking. Just like carbon, 1/12th of the carbon. Suppose if you want nitrogen means, what is the nitrogen? N714. So, if you use nitrogen means 1/14th of the mass of the nitrogen atom. That also equal to 1 AMU. Is it so? 1/14th of the mass of the nitrogen atom also will give AMU. 1/12th of the mass of the carbon atom AMU. Okay. And 1/4th of the mass of the helium atom. That also AMU. Is it so? Now, question is, why carbon they mentioned? Why they have chosen carbon other than some other element? I think you understand the questions, no? Try to find the answer. Already some questions previous chapter I asked. As you forgot, so I left. At least try to find the solution for this question. I remember that previous chapter questions. Any questions?
DVD.
Expansion of DVD. No, DVD storage capacity. Found or not? No. Okay. Take your own time, but not more time. Okay. Now, 1 AMU is equal to 1.66 into 10 power minus 27 kilogram. 1 minute. In color, I will 10 power minus 27. I will just edit it. Okay. So, 1 AMU equal to 1.66 into 10 power minus 27 kilogram. This and all noted. And energy equivalence of 1 AMU is 1 AMU equal to 931 MeV. What is MeV? EV is, just now only we discussed. What is EV? Electron volt. MeV means million electron volts. Okay. 1 MeV equal to 10 power 6 EV. Okay. Million is 10 power 6. So, energy equivalence of 1 AMU is 931 MeV. That is 1 AMU converted to energy, that is 931 MeV. Okay, clear? Right. Can we move to next topic? Discovery of neutrons. Neutrons were discovered by Chadwick in 1932. When beryllium is nuclei are bombarded by alpha particles. Alpha particle means, what is alpha particle? Helium nuclei. Alpha particle is helium nuclei. When beryllium nuclei are bombarded by alpha particles, highly penetrating radiations are emitted, which consists of neutral particles, each having mass nearly that of proton. These particles were called neutrons. And alpha particle is He24, helium nuclei. 2 is the atomic number, 4 is the mass number. Beryllium Be49 gives N01. What is N01? That is neutron. What is the charge of neutron? Neutral, that is 0. And mass is 1. And carbon, that is C. Carbon is Carbon only, no. 4 plus 2, 6, yes. C612. Okay. So C612, that is carbon. See, I think balance, no? 9 plus 4, 13. That is, you want to check, just like chemistry, here also you can balance the equation. That is a mass number A. Here 9 plus 4, 13. Reactant side. Same way, in product side, 12 plus 1, 13. What about its proton number? 4 plus 2, 6. And here also 6 plus 0, 6. So it's balanced. Charge is balanced and mass is balanced. Next, a free neutron decays spontaneously. What is the meaning of spontaneous? Spontaneous means what? Not continuous. Naturally, suddenly, naturally, without any external agency, without any inducement. That is a spontaneous. Without any triggering. Okay, naturally. A free neutron decays spontaneously with a half-life of about 900 seconds into a proton, electron and antineutrino. Nu bar is the antineutrino. Actually, nu is the neutrino. In terms of atomic number and mass number means nu 0, 0. That is neutrino. Okay. Nu bar is the antineutrino. Antineutrino means everything is same, similar, but its spin is opposite. That is antineutrino. How neutrino and antineutrino will be means everything is similar. Only difference is neutrino is, for example, spin is in clockwise direction. Then antineutrino will be in anti-clockwise direction. That is the only difference. Nu bar is the antineutrino. Okay. This is also 0, 0 only. Charge 0, mass also 0. Neutrino, both neutrino and antineutrino are the chargeless and massless particle. Okay. Can we move to next? Size of the nucleus, already we have given in slightly as R equal to R naught into A power 1 by 3. R equal to R naught into A power 1 by 3. R naught is a constant value 1.2 Fermi and A is the, what is A? A is the atomic, A is a mass number. Is it so? A is a mass number and R naught is 1.2 Fermi. This implies that the volume of the nucleus is proportional to R cube is proportional to A. Volume, that is a V equal to R cube. Where is the cursor? Oh, it's white. V equal to, what's the shape of the nuclei? Spherical shape. So 4 by 3 pi R cube, and so volume is proportional to R cube and this R is proportional to A power 4 by 3 pi into R is R naught power 3, that will be another constant will be there, into A power 1 by 3 whole power 3, 3 getting cancelled, so A. Therefore, V is proportional to A, that only. Volume of the nucleus is proportional to R cube and it is proportional to A. Okay. Density of nucleus is constant, independent of A. Density of nucleus is constant, it is independent of A, whatever element may be. For all nuclei, and density of nuclear matter is approximately 2.3 into 10 power 17 kilogram per meter cube, which is very large as compared to ordinary matter. For example, water density is 1000 kilogram per meter cube. Volume of the, density of water is 1000 kilogram per meter cube. See, compare this with nuclear density is very high. Nearly 10 power 14 times greater nuclear density. It is the densest particle. Okay. Can we move to next? Okay. Mass energy equivalence. Already yesterday itself I quote this formula, E equal to mc square. Einstein got Nobel Prize only for, not for this, yes, not for this equation, but photoelectric equation. Einstein's photoelectric equation, that is the energy E h nu equal to kinetic energy of the particle plus work function. There, for that purpose only he got Nobel Prize. And mass energy equivalence for, not for this, but everybody known Einstein for this formula only, E equal to mc square. Einstein proved that it is necessary to treat mass as another form of energy. He gave the mass energy equivalence related as E equal to mc square. I think this derivation you have in previous +1 or +2, no? Einstein? 9th standard. No, that big derivation, final derivation, that probably 2 to 3 page. In state board you studied, is it so? Derivation there, +1 or +2? 11th standard. 11th standard. In CBSE. You are CBSE, no? Okay, I think in CBSE is not there. Probably, actually derivation is there. E equal to mc square, sum of the kinetic energy and potential energy, and integration, differentiation. Without knowing integration, differentiation in mathematics, students have to learn basic of integration and differentiation in this. By applying integration, differentiation, we will get this equation, E equal to mc square. Okay. Here m is the mass, that is the loss in mass, and c is the velocity of light in vacuum. And mass defect, already we discussed. Difference between the rest mass of nucleus and sum of the rest mass of its constituent nucleons. That is only mass defect. Delta m equal to ZMP plus A minus ZMN minus m. Some place we may use capital M also for instead of this. Instead of small m, there may be capital M also, that is the mass of the nucleus. Mass of the nucleus. Okay. So, delta M is the mass defect. Binding energy. Binding energy is the energy required to break a nucleus into its constituent protons and neutrons. Already we know that is nucleus contains protons and neutrons. And energy required, there will be a bond between these two. There will be a attraction between these two. That is only proton and neutron attracted by a force called nuclear force. And energy required to break this proton and neutron separately, that is called binding energy. Binding energy is the energy required to break a nucleus into its constituent nucleons. That is only protons and neutrons, and to separate them to such a large distance that they may not interact with each other. It may also be defined as the surplus energy which the nucleus gives up by virtue of their attraction, which they become bound together to form a nucleus. That is another definition. And binding energy of a nucleus XZA is ZMP plus A minus ZMN minus m. What is m? M is the mass of the nucleus into c square. Just like Einstein's formula. Einstein's formula E equal to mc square. And m is the mass defect formula. That is del eta m into c square. Delta m value substitute into c square. Then that is binding energy. Binding energy is the minimum energy required to break a nucleus into its nucleons, constituent nucleons. Okay. Binding energy per nucleon, that is Be by A. Binding energy per nucleon is the average energy required to extract one nucleon from the nucleus. Average energy required to extract one nucleon from the nucleus. That is called binding energy. Okay. And this binding energy per nucleon only decides the stability of an element. Stability of an element. Suppose B by A value is large, then it is highly stable. Which element will be highly stable? Means iron. There will be binding energy curve will be there. In the binding energy per nucleon for iron will be highest, approximately 8.8 MeV you may get. 8.8 MeV. That is for iron. Binding energy for iron. And already we mentioned dividing the binding energy of nucleus by its atomic number. That is the binding energy formula we know, Z(M.P) plus A minus Z(M.N) minus capital M or small m, that is the mass of the nucleus, into C square divided by A, its nucleon number or its mass number. That is only binding energy per nucleon. We may think what purpose we are studying means this only decides the stability of an element. Uranium is, most of the uranium is unstable. Why? Means its binding energy per nucleon, sorry, E I put. Binding energy per nucleon value for uranium is less. That's why it is unstable. Okay. Noted? Nuclear force. Nuclear force or the strong and attractive force which hold protons and neutrons together in a tiny nucleus. Just to we can't say it is the strongest force. We want to compare with one force. For example, everybody know gravitational force. What is gravitational force? It is a force between, what is gravitational force? Come on. Force between an object and earth. Force between our body and earth. Suppose if you throw any object, ball or whatever thing, what will happen? It will again fall down to earth. Why? That is because of gravitational force. Same way, earth revolves around the sun. That is due to gravitational force. And moon revolves around the earth due to gravitational force only. All the satellites revolve around the earth. That's also due to gravitational force. Okay. And so we may know, now we can imagine the gravitational force, amount of the gravitational force. And if we assume gravitational force as 1 Newton, then nuclear force will be 10 power 40 Newton. Okay. Actually, basically 4 forces are there. In there, nuclear force is the strongest force and gravitational force is the weakest force. That will be 1 Newton. If we assume gravitational force as 1 Newton, then Newton force will be 10 power 40. 10 power 40 means 1 followed by 40 zeros. Okay. Now you can imagine the value of nuclear forces. And these are short range forces which operate over very short distance of about 2 to 3 FM. What is FM? Suryan FM. Fermi. Fermi. 1 Fermi equal to how much? 1 Fermi equal to how much? 10 power minus 15 meter. Just now only we discussed. And these are short range force which can applicable or dominate only within 2 to 3 Fermi or femtometer. FM means femtometer or Fermi. Okay. Between any 2 nucleons. Suppose 2 nucleon, its distance is 2 to 3 Fermi, then only force will be there, nuclear force. Otherwise, no force. And third one, nuclear force does not depend on charge of the nucleons. Okay. What is the charge of proton? Proton. Positive. Another proton, that also positive. Suppose if you bring two proton together, what will happen? It should repel. But inside a nucleus, proton with the proton also attract only, no repulsion. When it will be possible? If the distance is within 2 to 3 Fermi. Okay, distance is within 2 to 3 Fermi, then whether proton-proton or proton-neutron or neutron-neutron, that is attractive only. So nuclear force, what is the actual nuclear force? That will be proton-proton force or proton-neutron force or neutron-neutron force. All are called as nuclear force only. It's an attractive only, no repulsive force. Okay, that's only nuclear force does not depends on charge. It is a charge independent. And already we have discussed the nuclear density. Nuclear density equal to nuclear mass by nuclear volume. Nuclear mass is mv and nuclear volume 4 by 3 pi r cube. And if you substitute and simplify for given value, you will get 2.9 into 10 power 17. And 10 power 17 kilogram per meter cube is the highest density. There is nothing beyond this density so far known for on the earth. This is the maximum density, 10 power 17 kilogram per meter cube. Okay. Can we move to next topic? Radioactivity. Radioactivity is the phenomenon of spontaneous disintegration of the nucleus of an atom with the emission of one or more radiations like alpha particle, beta particle or gamma rays. What is radioactivity? Is a phenomenon of spontaneous disintegration. Already we discussed what is spontaneous meaning. What is spontaneous? Naturally, no inducement, by itself. Spontaneous disintegration of nucleus of an atom with the emission of one or more radiation. That radiation may be alpha particle, beta particle or gamma rays or alpha ray, beta ray, gamma ray. Already we know what is alpha particle. It is nothing but helium nuclei. What is beta particle? It is nothing but electron. Gamma is an electromagnetic waves. And the substances which spontaneously emit penetrating radiation are called radioactive substance. For example, uranium like some element spontaneously without any bombardment or without any triggering, it may emit alpha particle or beta particle or gamma particle. Then we can say that is the radioactive substance. Substance which spontaneously emit penetrating radiation. Radiation may be alpha ray, beta ray or gamma ray. Then radioactive displacement law. It states that when a radioactive substance or nuclei emits an alpha particle, atomic number decreases by 2 and mass number decreases by 4. That is, if there is an emission of alpha particle, suppose alpha particle is emitted, alpha ray is emitted for a given element X is at, X is at A. Then resulting element will be, I am keep as Y. Resulting element will be reduced by 2, atomic number is reduced by 2 and mass number is reduced by 4. Plus alpha particle already we said He24. Okay. So this only mentioned. When a radioactive nucleus emits an alpha particle, atomic number decreases by 2 and mass number decreases by 4. Okay. And for a nucleus emit beta particle, its atomic number increases by 1. That is, for X is at A gives beta particle emission, then Y. How is the beta particle? It's nothing but electron, E minus 1, 0. That is only beta particle. So, how is that? Its atomic number increased by 1 and mass number no change. This is the beta emission, beta decay. This is alpha decay and this is beta decay. And gamma decay or gamma ray emission. In emission of gamma particle does not change the mass number or the atomic number of the radioactive nucleus, but it lowers its energy. For example, X, Z, A. If there is an emission of gamma ray, then also X, Z, A only, and this may be in the higher energy state as X, Z, A star, and this will be in lower energy state. The star represent it is in higher energy state or excited state. That is represented by this star. Okay. So, in gamma particle or in gamma decay, there will be no change in the atomic number or no change in the mass number. There will be a change in the energy state only. Okay. So, this is the alpha decay, beta decay and gamma decay. Already we discussed. See, X Z A gives Y Z minus 2, A minus 4Y plus Hc24 plus Q. Some amount of energy will be emitted. This is the alpha decay. Process of emission of alpha particle from a radioactive nucleus and represent as XZA means Y Z minus 2, A minus 4 plus Hc24, that is only alpha particle plus Q. Q is the amount of energy, emitted amount of energy. Okay. Next to beta decay, same way. How is it? In beta decay, its atomic number is increased by 1 or decreased by 1? Increased by 1. Atomic number increased by 1 and with nu bar. What is nu bar? Already we discussed. Nu bar is a, nu is a neutrino, nu bar is the anti-neutrino. Anti-neutrino, that is nu bar. Okay. This is beta decay. Next. Can we move to next topic? In gamma decay, see, excited state. That I mentioned as star there. Here is mentioned as excited state. There is no change in the atomic number or mass number, but there will be a change in the energy state. Excited state to ground state with gamma emission. This is the gamma decay. Okay. Radioactive decay law. It states that number of nuclei disintegrated of undecay radioactive nuclei present at that instant may be written as n of t equal to n0 into or n0 into e power minus lambda t. N of t is the number of nuclei disintegrated of undecayed radioactive nuclei present at that instant, t instant. At t time, number of nuclei disintegrated from undecayed radioactive nuclei. N0 is the number of nuclei at t equal to 0, sorting time, initial time, that is only at t equal to 0. And here lambda is called disintegration constant or decay constant. Here lambda is called disintegration constant or decay constant. And it is defined as there is a decay constant is defined as the reciprocal or the time interval in which the number of active nuclei in a given radioactive sample reduces to 36.8% of its initial value. That is the definition for decay constant or disintegration constant. It is the reciprocal or the time interval in which the number of active nuclei in a given radioactive sample reduces to 36.8% of its initial value. Half-life. Half-life of a radioactive substance is the time in which one half of its nuclei will disintegrate. Suppose 100 number of atoms are there, then 50 number will be present and 50 number will be disintegrate. Then we can say that is half-life. Okay. Half-life of a radioactive substance is the time in which one half of its nuclei will disintegrate and depends on different elements. It is inversely proportional to the decay constants of the radioactive substance. That is T of, or simply T we may use capital T, that is equal to 0.693 by lambda. 0.693 by lambda. Here lambda is the decay constant. Relationship between half-life and lambda value is inversely proportional. T of is inversely proportional to lambda. Then, apart from half-life, one more thing is there, that is called mean life. Mean life is denoted by a symbol tau. And mean life is defined as the ratio of the combined age of all the elements and the total number of atoms in the given sample. That is tau equal to T of by 0.693. Tau equal to T of divided by 0.693 equal to 1.44 T of. That is a 1 by 0.693 will be 1.44. So tau equal to 1.44 times of T of. T of is the half-life. Tau is the mean life. And number of atoms left undecayed after n half-life is n equal to n naught into 1 by 2 whole power n. That is equal to n naught into 1 by 2 whole power t by 2. And from this, in some problem we may use n equal to t by t. From this lot of problems we are going to discuss later. N equal to t by t. After t second, n equal to n naught into e power minus t by tau. Okay. Okay. Rate of decay or activity of a radioactive sample. Rate of decay or activity. It is the number of radioactive disintegration taking place per second in a given sample. Number of radioactive disintegrations taking place per second in a given sample. It is expressed as R of T or activity, or some places we may use activity itself. Activity equal to dN by dt equal to lambda into n. And n equal to n naught into e power minus lambda t, that we know the formula. And unit of activity is Curie or Rutherford. Curie is the SI unit of decay. 1 Curie is the decay rate of 3.7 into 10 power 10 disintegrations per second. Okay. Curie is the SI unit of decay, and 1 Curie is the decay rate of 3.7 into 10 power 10 disintegration per second, and other units are there, that is Rutherford. 1 Rutherford is the rate of decay of 10 power 6 disintegration per second. That is 1 Rutherford. Just like meter also, yes, meter also unit of length, centimeter unit of length, and kilometer unit of length, inch unit of length. Like that, Curie also unit of activity or decay, and Rutherford also same. That is Rutherford, 1 Rutherford equal to 10 power 6 disintegration per second, and 1 Curie equal to 3.7 into 10 power 10 disintegration per second. Okay. Natural radioactivity. It is the phenomenon of spontaneous emission of alpha, beta, gamma radiation from the nuclei of naturally occurring isotopes. That already we have discussed. Now, artificial radioactivity or induced radioactivity. It is a phenomenon of inducing radioactivity in certain stable nuclei by bombarding them by suitable high energy subatomic particle. That is, for example, U-92-235. That is a naturally occurring unstable uranium example.
Tungsten also there is.
Isotopes. And that is not sufficient, because if you compare even carbon also, 6612 and 6614, 6612 will be 99%, 6614 will be very small percent. And to determine carbon dating and all, we need more C14, carbon 14. So it is required to, or we are needy or necessary to convert more amount of radioactive element. So artificially it's possible to produce that only, artificial radioactivity or induced radioactivity. It is a phenomenon of inducing radioactivity in certain stable nuclei by bombarding them by suitable high energy subatomic particle, bombarding with neutron, bombarding with proton, bombarding with electron,
Gold also.
or bombarding with gold. Gold bombarded with alpha particle. That is called Rutherford scattering, alpha scattering. In that Rutherford alpha scattering only, he found that something is present at a highly denser particle. Later only he found that that may be nucleus. That should be nucleus. Okay. So using gold foil, he did the research. Nuclear fission. Actually, nuclear reaction is two types. One is nuclear fission, another one nuclear fusion. Nuclear fusion. First we will discuss nuclear fission. Heavy unstable nucleus breaks into smaller parts. That is, what is nuclear fission? Process of splitting or breaking of heavy nuclei into lighter nuclei. Process of splitting of heavy nuclei into lighter nuclei. Heavy nuclei into lighter nuclei, that is only nuclear fission. An energy of about 200 MeV is released and 3 neutrons are emitted when U-92-235 splits by impact of slow neutrons. U-92-235, which is isotopes of uranium, bombarded with neutron, slow neutron or thermal neutron. Okay, the neutron will be a slow neutron or thermal neutron. Then it becomes U-92-236 in excited state. And that decay into barium and krypton with 3 neutrons are emitted with the energy liberated of 200 MeV. Okay, that is 200 MeV, 200 into 10 power 6 electron volts. So uranium, when it is bombarded with slow neutron, then it becomes barium and krypton, splitting of heavy nuclei, U-92-235 nuclei into barium krypton lighter nuclei. Therefore, it is a nuclear fission reaction. And atom bomb is based on nuclear fission. About 99.9% of energy is converted into heat, and rest is only converted into kinetic energy of neutron, gamma ray, light ray and product nuclei. So most of the energy will be emitted as heat radiation only. Okay. So that is the principle for atom bomb. Into next. And actually this nuclear fission reaction acts as a chain reaction. We said no, that is a barium, that is a uranium nuclei first. uranium when it is bombarded with single neutron, slow neutron. Then barium and krypton are emitted with 3 neutron. And these 3 neutron again bombarded with the neighboring uranium, and 2 more barium krypton with 3 neutron or 2 neutron, like that will be emitted. So this is for n equal to 1 stage, second stage, third stage, like that. See how it happen? Here 3 fission, 3 power 2. Here 3 power 3, 27. It goes like a chain reaction. Okay. So this is called nuclear chain reaction. And suppose if it is goes as it is, then that is a principle for atom bomb. That is only atom bomb or nuclear bomb. Suppose we are controlling that each time only 2 neutrons are emitted or only 2 fission takes place, then that is called a nuclear reactor. If you control the neutrons, emission of neutron or emission of fission reaction, then that is called a nuclear reactor. If it is not controlled, that is an atom bomb. Okay. Yes, nuclear reactor. It is in which energy is generated by controlled nuclear fission. We said no, that is a 3 neutrons are emitted here, and every stage 3 neutron means it goes like a chain reaction that leads to atom bomb, big explosion. And if it is controlled, then that is called nuclear reactor. And some of the important parts we are using in nuclear reactor: fuel. What is fuel? Fuel is material like uranium, U92-235, U92-238, plutonium, Pu-94-239, which can undergo fission by a neutron. So that is called fuel. Moderator. Moderator is a material like heavy water, graphite and beryllium oxide can retard and control the fast moving neutron. Okay, that neutron speed will be reduced or controlled. That is the moderator. Example: water, graphite, beryllium oxide, etc. Water, heavy water. What is the symbol for heavy? What is the molecular formula of heavy water? D2O, deuterium oxide. And coolant, material like cold water, cold air current, heavy water, liquid oxygen can absorb heat generated inside. So that is acts as a coolant. That is a coolant. Control rods. Rods of material like cadmium which can control the rate of chain reaction. I said no, every stage 3 neutrons are emitted. That neutron must be absorbed by one type of special rod, that is called cadmium rod. Cadmium rod is a control rod. It controls the emission of neutron for every stage. So by controlling this, we can convert this nuclear energy into domestic energy, useful electrical energy. Controlled chain reaction is slow and needs only 1 neutron for further fission. See, every time 2 neutron, 3 neutrons should not emit. For every time 1 neutron for further fission, on which control is possible. That is the principle for used in atomic reactor. Atomic reactor is the basis of controlled chain reaction. And if it is not in under control, that leads to atom bomb explosion. More than 1 neutrons are emitted in each fission, that leads to uncontrolled chain reaction, that is called atom bomb. Okay. Nuclear fusion. Where is nuclear fusion takes place? Nuclear fission takes place in nuclear reactor, okay, or in atom bomb. Where is nuclear fusion takes place? It's also occurring naturally. That is, a nuclear reactor is not natural, but nuclear fusion takes place naturally. That is a basic source for our Earth. Sun energy or all the star. Actually, sun is burning and emitting energy continuously for many years, around even 5,000 million years. More than 5,000 million years. Continuously it's supplying energy, is it so? And What is the fuel present inside means that is only hydrogen. Okay, hydrogen is the fuel present inside. And what kind of reaction takes place inside? Is it any chemical reaction? No, it is a nuclear reaction, nuclear fusion reaction. And what is nuclear fusion reaction? Fusion reaction is nothing but process of joining of lighter nuclei into heavy nuclei. That is hydrogen nuclei fused to form heavy nuclei helium. That is called nuclear fusion reaction. What is nuclear fusion reaction? Process of fusing of lighter nuclei into heavy nuclei. That is called nuclear fusion with the liberation of energy. That is H114 give equal to He24 plus 2E plus 10. What is E plus 10? Okay, what is nu? Nu we use in many places. What is nu? Nu is a neutrino. We used anti-neutrino, no? Like that, this is nu, neutrino. And what is E plus 10? What is E minus 10? Yes, previously and all we used. In beta decay we used.
Plus 1 beta, minus alpha.
Alpha. Beta particle is a negatively charged particle. Actually, E minus 1 is only beta particle or beta ray. Okay, and E plus 10 is, E minus 10 is electron. Is it so? Electron. And E plus 10 is positron. Just like we studied nu bar. What is nu bar? Anti-neutrino. What is anti-neutrino? It is an antiparticle of neutrino. Just like that, antiparticle of electron is positron. Okay. Antiparticle of electron only positron. Clear? Then, temperature should be high, about 10 power 7 Kelvin. Temperature is very, very high, 10 power 7 Kelvin. That is around in million degrees Celsius or in million Kelvin we need. Pressure should be large, about 10 power 6 atmospheric pressure. High atmospheric pressure, 10 power 6. And the kinetic energy of interacting nuclei must be greater than Coulomb repulsive energy. Kinetic energy of nuclei must be greater than Coulomb repulsive energy, then only fusion takes place or just like attraction takes place. And that value will be about 0.1 MeV. Then hydrogen bomb is based on fusion. Hydrogen bomb is based on fusion and atom bomb is based on fission. Normal that Hiroshima Nagasaki is a nuclear fission or nuclear fusion? Fission. Nuclear fission only. And hydrogen bomb is a nuclear fusion, very, very rare. And hydrogen bomb emitted energy very, very high, but energy or temperature required also very high. See, atmospheric pressure will be 10 power 6 atmospheric pressure, temperature 10 power 7 Kelvin. Then hydrogen bomb will be possible. Okay. Thermonuclear energy. The energy released during nuclear fusion is called thermonuclear energy. Protons are needed for fusion while neutrons are needed for fission process. That is hydrogen plus hydrogen. This is nothing but proton. H11 is proton. Okay. So, for nuclear fusion, we need protons. For nuclear fission, we need neutrons. And fusion reactors are better than fission reaction because harmful radiation are not produced. But temperature should be very, very high. 10 power 7 Kelvin. That is a million degrees Celsius or million Kelvin. Achieving is very difficult. That is one of the drawback or costly. Otherwise, fusion reaction will be easy and suppose suddenly it will burst means there will be no harmful radiation. Okay. Only heat energy will be liberated, no other harmful radiation. Proton-proton cycle. This is a nuclear reaction takes place in sun. This cycle is a source of energy in the sun, that is H11 gives He24 plus 2 positron plus 2 neutrino plus 27 MeV. And temperature in sun will be 1.5 into 10 power 7 Kelvin. And carbon-nitrogen cycle, that is some bigger star, carbon-nitrogen cycle will occur. Actually, sun is a small star. Compared to other star, sun is considered as yellow dwarf stage. It's a tiny, dwarf means tiny. Yellow dwarf. Okay. Yellow means color, and color that depends on temperature, and dwarf means small, tiny. So sun is a very small, and most of the stars will be very bigger star. For such a star, proton-proton cycle is not happening. Is the carbon-nitrogen cycle is occurring. That is, carbon with proton gives nitrogen, like that it goes, and finally carbon with nitrogen takes place. Carbon-nitrogen cycle. Next, carbon dating. Carbon dating is used to find the age of archaeological samples and the plant, etc. All the live plants and bones of animals have C614, which is in equilibrium with C14 in the atmosphere and remain constant as long as plant or animal is alive. But after the same dies, radiocarbon C14 continues to disintegrate, and the number of disintegration per minute decreases with time. Thus, the time taken by C14 to decay when the plant or animal died and ceased to assimilate C14 can be easily estimated. That is age of the mummy, age of the some wooden sample which is buried inside a snow or any rock, that can be calculated using carbon dating or radiocarbon dating or radiometric dating. Okay, that is the age of the mummy in Egypt, that can be calculated using carbon dating only. Okay. Okay. We will continue next chapter. Thank you. Thank you.